We're in the middle of chapter 12 in section 12.1, and we're looking at constructions in this section. We're about to start looking at some of these constructions as they relate to triangles. So let's take a look and get back involved with congruent triangles. All right, we've talked about congruent before. Congruent is the idea that something has the same measure in some fashion. So congruent angles, it means the angles are the same measure. It may not be in the same location or something like that, but they have the same degree measure. When we talk about congruent as they relate to triangles, it means that we have the two figures are congruent if it is possible to fit one into the other so that the corresponding parts are congruent. So within triangles, we're talking about lengths of the sides are all the same. I don't mean like equilateral, but I mean you can do them, you can pair them up and they match, between two triangles. And then all the angles do the same sort of thing. You can pair them up so that corresponding angles are congruent together. So you've got congruent sides and you've got congruent angles. We use the phrase corresponding parts of congruent triangles are congruent. And I have seen resources as I've been doing observations with student teachers and stuff, but sometimes you'll see this like this, CPCTC. Now, see people abbreviate that. It's all those letters, right, without the "the" in there and the "of" and stuff like that. So corresponding parts of congruent triangles are congruent. And we name congruent figures, we have to keep the vertices in order so that the congruent parts correspond. All right, so let me draw a picture on this slide. I've got some space of what we're talking about here. So if we have this image for our triangle, it's not really meant to look like a right triangle per se. And then we have the exact image. It doesn't have to be in the same, like I could take this, in fact, and I'm going to just for fun. It's like this now. Okay? They don't have to be in the same, what's the word I want? Orientation. That's the word I want. They don't have to be oriented the same way. But we have to be able to match up the sides. For example, we're going to say that this side, we're not going to say it, it is, it's congruent to that one. So we're going to mark them like that. And then this one down here was congruent to this one. And then the third side was congruent to the third side over here. So we have three sides, and the pairs match up so that the pairs of sides, as we match them, are congruent to one another. And the same is true for our angles. So we'll do the same thing with the angles. This angle right here is congruent to this angle right here. So you can mark them with an arc. You could put a hash on the mark, on the arc like this, if that's helpful to clarify. I'm going to leave mine without, so just do one. And then I'll do two angles right here, or two arcs right here for this angle. So those are the two angles right there that correspond to one another. They're congruent. And then our third set of corresponding angles is this other one right here. So you'll see markings like this to mark showing that congruent triangles are congruent. Okay, so in order for a triangle to be congruent, what really has to be true is that all of the sides pair up in a congruent fashion and all of the angles pair up in a congruent fashion, right? You really need 6 things to be true, for real, right? All 6. I mean, this has to work. But what we remember, and you probably remember as well, is that there are ways to sort of shortcut that so you don't have to actually check all 6 of those things, and you still have congruent triangles. And that's what we're going to be taking a look at next, is some theorems that say, okay, yes, we've got to have all these 6 things happening, but if we have 3 of them in a certain fashion, it will be enough to force the other things to happen automatically. That's what it's going to be. So let's take a look. So the first one is the side-side-side congruence theorem. This theorem says that if we checked all the sides and we had this, correspondence where the different sides paired up in this congruent fashion, that would be enough to force the angles to also work. That's what that says. If all sides of one triangle are congruent to corresponding sides of another triangle, then the triangles are congruent. Those angles are forced to have that congruence relationship as well. And I can't remember if it's next. Okay, let me show you. Well, I already drew this picture actually, so I'll draw it again just for fun. All right, so here's my triangle from the previous slide. So the idea is that if you had an image given to you, and I'm going to leave in the same orientation this time, and all you were told was the information, and all that was marked on the diagram was the information about the sides, and it looked like this, that would be enough to say that you know you have congruent triangles. And we're going to do a construction in a moment that shows how this works, and a little bit of why it works really too. The second one of these theorems is called the side-angle-side congruence theorem. So SAS, side-angle-side. And it talks about having two sides of a triangle and the angle that's between those sides congruent to the other triangle. So I'm going to use my same triangle. I'm just going to mark it differently so you can see what it's referencing. All right, so if you know, say this side and this side are congruent, and this side and this side are congruent, and the angle between them, it's called the included angle. It's this one right here, that this one is congruent. That again is enough to know that the other angle, the other two angles and the other side have to be congruent to one another as well. It's enough. Okay, the included angle. It is important that the angle is an included angle. If you used the other angle, like let's say for instance, it wasn't those that were marked, it was these that are marked, you would not necessarily have congruent triangles. Okay, that is actually a statement that is not an always true statement. Could they be? Yeah, they could, but they wouldn't have to be. Okay, so we want to make sure that we've got the included angle that we're referencing. All right, the next one is called the hypotenuse leg theorem. This one, in order for us to actually use the word hypotenuse, we must be talking about a right triangle, right? Because triangles don't have a hypotenuse unless they've got a right angle. So this is a right triangle theorem. So if the hypotenuse and the leg of one right triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. So let me draw a right triangle this time. That wasn't what I was supposed to do. Let's try again. Okay. Again, they don't have to be in the same orientation. But it says the hypotenuse, that would be this piece, right? And one of the legs, and it really does say one of the legs, so either of the legs is fine, so we'll just use the bottom one. So it's saying if you know this much information, that's enough. And let's talk about what else we know in this diagram. I haven't marked it, but what else really should my diagram be marked to have in it? A right angle, yeah. So down here in the bottom corner, this is a right angle. So notice that's not an included side, is it? It really is not. But we have more information because we have a right triangle. Does anybody remember what wonderful piece of information you actually have when the triangle is a right triangle? Yeah, we have the Pythagorean theorem. The Pythagorean theorem says that if I know two sides of the triangle, I could find the other one. So if I knew these two sides of these triangles, then the other one's automatically fixed, isn't it? Which means knowing two sides of a right triangle really means I know all three. So this really boils down to actually having the side-side-side congruence theorem. That's what it really does. Okay, so this is called the hypotenuse leg theorem. All right, so here's what we're going to do. We're going to do an example. We're going to find at least one pair of congruent triangles. So I'd like for us to pause for a second and for you to write them down. So we'll make sure everybody has them written right, but go ahead and do your best at what you think you should write for a pair of congruent triangles, not between number 1 and number 2. Just within diagram number 1, there's at least one pair of congruent triangles, okay? Within diagram number 2, there's at least one pair of congruent triangles. And actually, diagram 2 has more than that. So if you start to be creative, get done with one of them, see if you can find the other one, okay? So take a look and find the pair of congruent triangles that you see. And then we want to talk about how you know they're congruent too, so I won't put you on the spot, but think if you can figure out why you believe that's the case. Okay, did you guys get a pair of congruent triangles in the first one? There should just be one of them on this one. What did you get?
Triangle ABD and triangle DBC.
A, B, D, and what was the other one, Elena?
CBD.
Okay, so notice we put a triangle in front before them, right? There's an actual triangle symbol there. That's important. I'm also going to put the congruence symbol between them. Okay, so let's first talk about the ordering of what we're doing, and then we'll talk about why this is actually a true statement for this. Okay, so noticing this, angle D is what we're saying is congruent to itself right here. So the D has to be in the same location when we're writing down the ordering of our letters, right? The same thing's true for angle B. These two up here are identical. In fact, they show us that one identically, don't they? They actually tell us that one's congruent. So B is actually listed in the middle as well. And then A and C are the corresponding angles on the outside because those are the congruencies over here. So why is this one congruent? Which one of those congruence theorems led you to believe that this was the case? Side angle side. Very good. Why is this side angle side? They share a side. And it's actually not marked, but we recognize that in the middle, right, that side BD, they share that side. So it is congruent because it's the same side. And sometimes it's helpful if you're sort of having difficulty. This diagram's not too bad, but sometimes it's helpful to redraw the diagram. That was terrible. Let me try that again. To redraw the diagram, that was not any better. That one's actually pretty good. So we pretend we redraw the diagram, and then you could actually see where the markings are. This one's here, and then you actually know for sure that these two in the middle are the same because I can mark it that way. So sometimes it's helpful to redraw that. This one's not too bad, but occasionally that's helpful. We're going to redraw the next one in a little bit, okay? So what set of triangles did you see that are congruent on the second one? Somebody give me one pair of congruent triangles. Not Elena, because you gave me the last one. Somebody else.
Triangle ABD and triangle EBC.
Okay, do we have agreement to that? Does anybody else have that written down?
Does it need to be written differently? Do you have to go outside, like the same structure to it? So
Oh, okay. So you want us to rewrite the letters. I agree with you, Elena. So what should we write instead? Whitley, can you fix it? CBE. Yeah, we want to make sure that the orders match. That's a very good statement. Yep. So B is in the middle, the same. That one was okay. We want to make sure that the angles are actually corresponding. So like this pin right here is equal to this one. And there's some reasons for that we'll talk about later. But we want to make sure then that angle A is corresponding to angle C in our list of letters. Did anybody get a different set of triangles? Or as I was telling you, I think there's another one you should be able to find. Did you find one? What is it? Did anybody find it? Elena says she did, but did anybody else? What did you find, Kaylee? Give it a shot.
ABE.
Okay, and what's the corresponding triangle then to that? What do you guys think? They overlap, so it's a little bit hard to see on this one. We're going to go back here in a minute and justify why we know this, but this is one of the triangles in red. Okay, and then this is the other triangle in blue. So the angles, they still have the same angle here on the edge. They still have these same sides marked, and they still have the same sides in the middle marked. They actually still have all the same components that they did before, but in a different way. So let's talk about how we know that each of these congruencies happen then. How about the first one? Why is triangle ABD congruent to triangle CBE? Oh, it's side, 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 isn't it? Yeah, we've got lots of sides marked on this one. What about this one down here? I mean, there's nothing really that marks side AE, but then how do we know that AE is congruent to DC? Because that's what we have to know in order to say that one's side, 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 right? How do we know that?
Same.
What's the same?
DE is equal to line segment DE.
Right. So if we sort of thought about it maybe in a little bit of an algebra sense and we called this one X, then this one would also be X because they're the same length, correct? And whatever we want this to be in the middle, I'll call it something different, Y. Then this length is X plus Y and this length is X plus Y. They're the same because they have that overlapping piece in the middle. So I do still have side, side, side for that. Does that make sense? There's one more feature in this, and we will come across this later, but just because we're already here, I'm going to make mention of it now, and then, like I said, we'll talk about it again. But, hang on. Okay, I give up. I mentioned a moment ago that this angle and this angle are congruent, and we know now for sure that they really are because we've got these side-side-side congruence, so the triangles are congruent and all that good stuff. But does anybody know another reason, just something that you remember from the past about why those two would have to be congruent? You may not, but does anybody?
Is it because it's isosceles?
You got it, Matt. Very good. This is isosceles triangle. Is that part okay first for everybody? Do you agree we got an isosceles triangle? The big one on the outside is isosceles? Yeah. And there is a theorem. We'll encounter it later. I don't know if it's today or if it's tomorrow. We'll figure it out when it is. But it says that if I have an isosceles triangle, that the base angles, that's what A and C are down here, are going to be congruent. And in some sense, the reason is exactly because of what's happening over here. This is an isosceles triangle, right? And if I break apart the isosceles triangle into two congruent pieces, you know, two congruent angles in the middle there and drop it down, I get these two congruent triangles. And it always works that way. So isosceles triangles have that characteristic. Like I said, we'll talk about it more later. But all right, we have two more congruence theorems. The next one is called angle side angle, which is good because we had side angle side, we have angle side angle. They sound very similar. So it's this idea of trapping one of these measurements between something else. So if I have a triangle, let me try that again because otherwise it looks too much the same for me to actually get the correspondences done right. Okay, so I have these two right here. And what I know now instead marked is I've got one angle and I've got another angle. I don't even care which one it is. Okay, I've got two angles. And the language even says angle, side, angle, which means the side has to be between the two angles. So this side is the side that we're referring to. So if that is what we know, the angle and the included side, we also have congruent triangles. Side has to be between the angle. If the side is not between the angle, something else is happening. Okay, this one. This is the side that's not between the angles. It's our last congruence theorem. If you have two angles that are opposite, hang on, let me get my triangles drawn in here. There we go. All right, we have these two angles in a side opposite one of these two angles are congruent. So the deal is I've got two angles, so let's just mark these two this time for fun. Oh, and I shouldn't have marked it that way over here too. I didn't intend to make these sort of look like that they were congruent to each other. Please fix that. They're just congruent between the two triangles. Okay, so we've got these two angles congruent on this triangle. And we have a side, but it's not the included side. So let's say it's this one. That is also, again, enough information to finish the picture. And in some sense, this kind of makes sense, and here's why. If the other one is true, so if we go upon the idea that we know that this one works, this one has to work because if you know two angles, measures in a triangle, can you always find the third? Yeah, because they sum to 180, right? So if I know two of these, I automatically get the third one. So if I automatically had the third one, wouldn't I now have angle, side, angle anyway? I would, because I know two angles, and there's now a side that's between two of the angles I know. So I almost get this one really for free. There are some things that don't work, though, okay? The first one that doesn't work is angle, angle, angle. If all you know is that the angles of the triangles match up, that's not enough information. And this is a really good picture for why. It's blown up from the other one, right? Yeah, so that's not enough information. All you have to do is to put it on the copier and press enlarge, 150%, right? You have a non-congruent triangle that have congruent angles. This one's the one that people will sometimes want to be true. Side-side angle. So you can remember that this one doesn't work because if we switch the word around, it's a bad word. Okay, let's keep that in mind. Side-side angle, no good. And here's why. So I'm going to have to talk through this one a little bit with you. But in this picture, we have two triangles that have two sides and an excluded angle, like not the angle between them, that match. But these two triangles in this picture are clearly not congruent. Agreed? The two sort of pieces that are broken apart. I know we've got three triangles because I got the big overall triangle. But the two smaller triangles in this picture are clearly not congruent. So let's take a look at what we actually have. All right, so we have, excuse me, this side and this side that are congruent, right? Oh, I think you're going to break it apart in a different way, the way that this one was drawn. I apologize. The other one down here is that we're going to use this side down here congruent to itself. So let me draw the triangle out, the two triangles out separately so that you can see where they're coming from. We've got this triangle here. So this one is A, D, B. And then we've got, oh, I need to move that over. I don't have enough space. Let me move that. And then we've got this one down here. And instead of it connecting the way that it did up to D, it's going to connect further up here. What did they call it? C? So let's actually mark on here what we have. We know that DB and CB are the same. We know that this side AB is itself. It's the same. And we have an excluded angle over here, angle A. That's exactly the same. An angle, two sides that do not surround the angle, created two triangles, and these triangles are clearly not congruent, right? The third sides are not congruent, that third angle, both actually the second and third angle are all not congruent. Everything else just falls apart. So we do not have a side-side angle theorem. All right, so let's take a second, and I want you to take a look at this one. It says, for each of the following, find at least one pair of congruent triangles and tell why they are congruent. And for some reason, number one is not marked on letters, so let's fix that. Let's call this A, B, C. Everybody has the same ones, and then we'll call this D, E, F. Okay, if you get your symbols in the same place I put mine, then we should have matching triangles when we're done. If you don't, then they're not going to match, but go ahead, take a minute. I want you to write down the congruent triangles you see, and then we're going to have a justification of why. It's side, side, side. It's side, angle, side. It's angle, side, angle, or it's angle, angle, side. Or hypotenuse leg, if we're dealing with right triangles. We actually have that one as well. So at least one pair of congruent triangles and why they are congruent. And when you're done with your 3, 1, 2, and 3, turn to a neighbor, compare. Make sure that you agree with theirs and they agree with yours. If you get stuck, no worries. We're going to come back together. All right, what'd you guys put on number 1? What'd you guys put? Oh, for you've hypotenuse leg. Okay, that's good. That's a good reason for that one. What is the congruence that you wrote down?
Triangle.
Which triangle? Yeah. Triangle what? ABC. Okay. Congruent to what? F. Will it be FDE or FED? ED. Now, you may not have them in this order, but they have to match up, right? So like, let's say you didn't write down ABC, you wrote down ACB. That's okay. It just means that your FED is going to be FDE, right? They just have to correspond to one another on your diagram too, okay? How about number 2? What's your we'll do the reason first because you guys were really excited to tell me reason on the last one. What's the reason on this one? Did you write down? You said angle, angle, side. I agree with you. Did anybody else have a different one? What did you put down, Elena?
I put down as it couldn't be congruent based off the drawing. Like,
Okay.
You can sit looking at it, we can tell it's congruent, but based off the markings,
Oh,
we
okay.
couldn't prove it was congruent.
Okay, so the markings, I agree with you. There is something that's not marked that's congruent. Jacqueline, you're shaking your head because you told me this one. What did you think was congruent that's not marked? There's vertical angles. Do you guys remember doing vertical angles in the last chapter? There are I know, it's like it came back up to haunt you, right? Crazy stuff. That's math for you. Okay, this one, it's congruent. But Elena's right, it wasn't marked. You had to actually use some knowledge about lines in order to actually know that. Once we have that, you're welcome to mark those things when you know they're facts to be true. I mean, you can mark them. And now that we have that, we've got that angle, angle, side. So let's write down a congruent statement. I'm going to just do ABC because I'm kind of a little OCD and I like to go in order. So that I like that. ABC. All right, so what is the triangle that's congruent to ABC? E, D, C. Look good? Great. All right. We've got a couple possibilities on this last one. What did you guys see? Not sure? Okay, that's all right. Let's do this triangle first. And this is one where, because the triangles overlap, it might really be easier to draw another picture. Does that make sense? So I would be tempted, if I were you, to do just that. And I'll draw it in red over here. I'll try and draw my picture over here, and we'll write the congruent statements on the other side. Okay, so here is A, B, D. And then the other diagram, or the other picture, triangle in the picture, that would match up with it is going to be down here. Okay, so I'll try and draw that one in a blue color. And that's E, A, C. All right, so let's mark the things that are congruent according to the picture from here. So let's start with maybe something about an angle or something in here, maybe. What do we see? Angle B and angle E. And those are marked, right? So this one and, well, hang on. This one and this one are congruent. What else?
I have a question for me. Can you say that line AC is congruent with AD? Because the way the drawing's drawn, it makes you believe that line segment AE is congruent to line segment AB.
Yeah, I'm wondering that about the diagram itself. So part of the question is, are they referring to this piece or are they referring to this piece when they put the congruence markers, right? And for the purposes of our discussion right now, let's go with this piece, and then we'll go from there. I think that's their intent on the drawing. I could be wrong. There's other ways to go about this, but I don't think that's their intent at the point when we're looking at the problem right now. So we're going to go with it marking actually meaning the whole length AD. So if we do that, we should be able to come over to here and mark these, correct? Yeah? All right, what else do we get to mark? There's something else we get to mark. A. They both share angle A. Like that, right? So it's angle, angle, side. Okay then, angle, angle, side. What are my congruence? What is my congruence statement then between these triangles? How about A something? How about ABD? ABD. What is ABD congruent to? What triangle? The A has to go together. What's next? E. And then C, right? Okay. Now here's the cool thing. If we were able to already say this statement, we could actually talk about another pair of triangles in here that are congruent now as well. What are those triangles that would also be congruent that we could start making another claim about if we were already established with what we just wrote down? Do you see these triangles?
So you just did that point as X or just triangle E?
You mean like what would we call this in the middle here? We could give it another name, yeah. So we're not going to go through this, but let's just talk about the fact that if we did know that, we would have these pieces of information. We could find out, or we could mark the fact that these two are the same length now, because we know that the whole length is the same, and this is just a portion of it. We would know automatically as well that these angles are congruent because we have the bigger triangles congruent. We'd also know for a fact, we could talk about the fact that we know this angle and this angle are congruent because they're supplementary, right? And we could even look at the fact that we would know these are congruent because they're vertical. And there's lots of pieces of this that we could kind of piece together the same way. We're not going to write all of those things down, but there's, you know, it's one thing leads to another once we start working within the diagram. This is the one that's the most easily worked with, though, from the diagram as it was given. All right, we're going to do 3 constructions. Count them. 1, 2, 3. All right, do you have your compass with you? All right, so the 3 constructions that we're going to look at are all based upon these ideas of kind of like the question of, but why is side, an included angle, and another side enough? Okay? And then the same thing for side. Actually, we're going to start with side, side, side. But that's kind of where this is going. And we have this sort of weird one sort of sandwiched in the middle here, talking about the angle congruence. And the reason it's there is because we need it for the 5th one. Okay? So the 4th one is talking about just getting congruent angle drawn, and then the 5th one's going to use that fact. All right, so the first one says that we're going to construct 2 triangles based on the fact that we know the 3 sides have these corresponding congruencies. Okay, so I'm going to pause this. If you're looking back at this video later, you can click on that link for video 3 that's inside of Moodle Rooms and watch a version of what I'm going to show you in there. All right, I'm going to write this at the end. I don't have space in the middle, so we're just going to move to the end and we'll write it there. We've got to be getting close. There we go. So now we're going to make it look like we have a chalkboard. How's that? Sound good? All right, so this is my side, side, side congruence theorem. So what is the first thing we did? We started with a triangle, so maybe we should actually write that down. So we start with a triangle and a straight edge, a line, okay? Start with a triangle and a line. Then what do we do? Our goal is to get 3 sides that are congruent. So what did we do to get the first side? We measured it with our compass, right? So we measured one side with the compass. And the reason we did it is so that we can mark it on that line, right? So So we marked that length on the line. Okay. So then we moved our compass back to that same triangle we started with, and we did a second side, right? So we measured a second side. Now, we had to be careful, and this is where a couple of you ran into some things that looked a little funky, is when we're measuring a second side, we have to use, we'll say using the stationary end on one of the end points we already used. So in my triangle, that was A and C. We couldn't put the stationary end on B because then I wouldn't be able to move my compass and know where to put that stationary end when I moved it. It has to be one of the endpoints we already have. And we make an arc, right? I'll say on our new triangle, or new, how about new diagram? It's the diagram we're composing. And then we repeat step 3. I mean, that's really what we did. We repeated that with the other endpoint. The two arcs intersect in our third vertice. Our third vertex. And we draw two remaining sides. Right? Knowing those sides forced the angles to do something very specific. Be congruent, didn't it? We didn't have any options when we were doing it, and it forced those angles to be what we were expecting, which was congruent. All right, so the next one we're going to look at is creating congruent angle. Right? That's video 4. So let's take a look at how. All right, so we're creating a congruent angle here. So the step 1 is that we started with an angle and a line, right? What did we do next? We have this line. What do we do first, actually? What do we do first? I already have that in step 1. Yeah, but we did create our other lines, true. But what do we do after that?
Create an arc.
We did an arc. So we created an arc using the endpoint of our vertex. Okay, so we created an arc, and it didn't matter how big the arc was. It really didn't. It just needed to cross through my ray, my two rays. So we created, I'm writing this present tense, so create an arc with the vertex, and it's supposed to cross both rays. Or you could say crossing both sides of your angle, which are our rays. And then what did we do? We measured something. What did we measure?
The vertex to one intersection of where the ray intersected the arc.
We didn't measure it from the vertex, though. And actually, I'm ahead of myself. I need to write down one more step before I actually get to what I was about to write down. We need to duplicate this arc on the other image, right? So we, I almost forgot. So we draw this arc. We'll say along our line. Okay, so now we've got two arcs. The arc on the angle that we've got, and we've got an arc sort of on this line that we've got. The arc actually intersects the line and it goes further, right? How do we get the other ray? Because that's the other piece we need.
Measure the arc between the two intersections of the rays.
Very good. We measured the arc using our compass. We measured, every time I say measure, it's talking with the compass. We measured the arc between the two intersection points of where the arc intersected our rays. And we just transferred that to the other image, right? We moved our compass and we transferred that. To our new diagram. The intersection of the arcs. We're almost done, guys. The intersection of the arcs form the point to create our second ray. Right? And then we drew the second ray. So, I don't know, is this step 6 or 7? So draw a second ray. Was it 7, did you guys say?